guys want to see a project mess? Thought you might. So the standard disclaimer applies, and that is I'm no more qualified to give you electrical advice than I am to give you medical advice or any other advice for that matter. But with that said, let's take a look at how I did my electrical. And today we're only going to be talking about the DC side of the house. There's an inverter and 120 volt AC side that we're not going to discuss today. We'll do that in another video. There's enough to talk about with the DC stuff. So you've all seen this before. Here's our electrical box. So there's a lot going on in here, but the main thing to know is we have a 1 gauge wire coming off the positive of the battery. It goes through a fuse. It then goes through a disconnect switch so I can shut off the battery. This stuff down here are protection measures for my battery so that I don't have to pay any attention to anything at all. If something goes wrong with my charging equipment, like my solar, my inverter charger, and for whatever reason they go haywire and they try and overcharge my battery, the battery will recognize that and it'll disconnect the charging sources. That's one of these. The other one will disconnect the loads if the battery gets too low in power. So don't worry too much about that stuff. The main thing to look at are the fact that there are fuses that protect whatever size wire that you're using. So this is a 200 amp fuse that protects this 1 gauge wire. And this is sized at 200 amps because my inverter, when running in surge, has the ability to pull 166 amps. So I wouldn't want to size that fuse at 150 because if my inverter, let's say I turn on my induction top and had it set at too high of a setting, it would put my inverter into surge capacity and it would blow that fuse. We don't want that. So that's sized above what I think all my loads would be. And then the wire is sized to that. So with this switch we can turn off the whole electrical system. This one disconnects the inverter. The inverter hooks up to these two and sits right here. It's just not in here at the moment. So when the power goes to get distributed on the DC side, that wire is connected to a bus here. That's a contactor, and then it goes through this 60 amp DC breaker. And this is 6 gauge wire. So I sized this wire for all of my loads. So this should be able to carry, this will be able to carry the full weight of everything if it was on at once and then some. So I determined that could be somewhere in the 40 to 45 amp range, and part of that are things that have a surge startup, like the compressor on the refrigerator. In any event, this is sized at 60 amps, and this would blow if there were a fault instead of melting wire and causing a fire. So after going through a breaker, these wires connect to the first distribution block, and that's right here. So at this point, you can see some labels. This goes up to our vent fan. This goes to the rear lights on the doors. There are a number of other things here that haven't been hooked up yet. But this distribution block serves some of the 12 volt items that need to run within this box and essentially on this side of the van. So a lot of my lighting is going to initiate on the side. The rear door lights and a few other things. So that's the first DC bus. We'll come back to that in a minute. So then initially when I drew up my wiring diagram, I had some Blue Sea power posts and the negative, there's a negative side and a positive side, and they would go to the power post first, and then power would get distributed to this. And then I realized that because these terminal blocks have a good post on them, I called Blue Sea and I talked to one of their ABYC certified engineers, and he indicated that I can use the lugs on their fuse blocks as a power post, so I could eliminate those additional pieces. So these are rated at 100 amps, so I can run any number of them in series as long as my total load doesn't exceed 100 amps. Clearly it won't, because the breaker would blow at 60. So what you see here is the positive providing power to distribution block, and then the power is leaving this distribution block on the same post. Same is happening on the negative side. So when it leaves here, it goes, the positive and negative go into these tubes in the floor and pop out on the other side. And I've done my best to try and protect the wire. So in places where there might be a sharp edge, I wrap it in something. You might also notice I have some strings here so that in the future, if I wanted to pull more wire through, I have a possibility of doing that. I have to say, this stuff, I know the stuff is designed for pulling wire. It's not the most friendly stuff. I've had trouble getting wire through it before, so just thought I would throw that caveat out there. So this wire then goes through just a piece of PVC pipe, and I'll attach it probably with zip ties so it's not just rattling around in there. And then it goes into another Blue Sea distribution block here at the galley. So we've got power coming in, we've got ground coming in, and there's going to be a 30 amp fuse here, and then that feeds this 8 gauge wire that goes up the wall and up here. And I think this is 12 gauge, so this is a little lighter duty. I think 12 gauge will carry, it depends on the length of the wire, but I think that could carry 20 or 25 amps. And up here I'm only going to have some charging ports and some under cabinet lighting. So that's what this is for. So on the end of this wire, inside of my overhead cabinet, there'll be another one of these distribution blocks. So basically what you have are 3 distribution blocks all in series, and they're all sized conservatively for the load I'm going to put on it. So the reason I have 3 is I don't believe that it makes sense to have run individual wires for every load from the electrical box all the way to each component. So that box, again, feeds everything on the passenger side of the van. This box will feed everything in the galley, which includes the refrigerator. This is the wire for the refrigerator that hasn't been plugged in yet. There'll be the carbon monoxide, propane alarm, water pump, and I think some lighting. That's what that one's going to feed. And then again up here we're just going to have a little bit of charging and some lights. So you're probably wondering what the rest of these wires are. So let's go back here. I ran a bunch of wires up this pillar. It's kind of hard to see. There we go. And what you're looking at is the stock wiring harness plus the Cat5 remote for the Magnum inverter. I ran a second Cat5 cable, and that's because if I want to add like a Victron battery monitor or something later, I'm not running one because my battery BMS already has one, but here's a data cable for future proofing later. And then this is empty. There's nothing in this. and there's a bunch of string wrapped around at the end, and that's for future proofing, so that at least I have a chance of pulling wire through that from the battery box in the future if I want to add something. And then on this side over here we have speaker wire. So this is all speaker wire. This one here is for the rear lights, and the rear lights are on a switch, separate switch, that one at the back, and there's also a USB charge point at the back. And this is our wire coming in from solar. And then this is where some of my light switches are going to be. So this is to the battery. So this is going to provide the feed to this box. And then ground to overhead light switch. So this will allow us to turn on and off the overhead lights by a switch that these holes are, by the way, for the stock door handle, but I added those switches there, and that will allow me to turn on or off the lights without having to open the slider door all the way and get in the van to access this. So the dimmer will be here so it can be reached from bed. There'll be a red overhead light and something else I can't remember right now. And then up in here we've got the S-bar thermostat and controller will be in the headliner here. So you're still seeing the audio wires up here. These are the DC wires that control the switches I just talked about. And then this is a 120 volt wire that goes down this pillar and it goes into the passenger seat pedestal, and that's where we have an inverter charger. I'm sorry, we have a second inverter, just a little 600 watt one that I can turn on, and it'll feed 120 volt power to the inverter charger at the back, and that's for emergency charging, just in case there isn't solar. Solar seems to take care of it all the time so far, so I haven't had the need for that, so that's for backup. So you'll probably notice that all of this blue conduit has nothing in it but strings, and that's again because I want to be able to, if I think of something I want to add later, be able to pull wire through here without having to pull the van apart. With overhead cabinets, I would have to pull overhead cabinets off the wall and then the headliner in order to access this. So I'm trying to think of as many things as I can. And then on the side where I've run the wire, I've just run the wire through leftover closed cell foam to protect it from the body. This is a lead for the subwoofer. The subwoofer is going to go here. Make sure that you label your wires as you're running them, because once the wires are in the wall, if you don't do this, you're going to have a hard time tracking down what these wires go to. So you want to label both ends, just as we've done over here. So that's an overview of the mess that we have going right now. But it's pretty close to being ready to get the walls and cover all this up. So let's go look at some of the parts that we've been using. I've been using this really good Ancor marine wire in a variety of sizes. I've used mostly 14.2 and 16.2. And this stuff, marine quality stuff, is always much better quality than RV grade. You don't want to use solid like Romex in a van, but I like that it's double shielded, so that gives it a little additional abrasion protection. But I've also been using this abrasion cable, so for places where the cable's passing through an area where it could be abraded, I like to run it through this, and then you can use heat shrink to attach it to the wire. So this has been really good stuff. Here's the slightly thinner 16.2. This is the Ancor 1 gauge that I've been using for battery cables you saw the Blue Sea fuse block. This is a smaller one I bought, and I realized that rather than this has 6 slots, the other ones in the van have 12. And I like the idea of having slots open for things I'm going to add later, so I pulled this one out. You saw some bus bars probably in the battery box. This allows you to land multiple wires in one location. These lugs, you always want to size these lugs for the size wire you're using. So in this case, this is for 8 gauge, and then this is for a number 10 screw. And that gives you a good connection. This doesn't go with this. So these Blue Sea boxes use a number 8 screw. So these are number 8 ring terminals for 14 to 16 gauge, and they have the heat shrink built into them. So you can put the wire in there, crimp it, and then give it some heat. And you've got their heat shrink built in. But they're sized for these terminals. And then I've also been using, I never seem to have the right ring terminal in the right size wire, and so I bought this multi-pack just recently. I should have done it a long time ago. And then we've got our, this is for crimping the big cables. I use this to crimp the smaller ones. All these products I'll go ahead and put on my product page in case you're interested in some of these. These are really quick. You've probably seen me use these for stripping wires. This comes with this for cutting the large cables. Zip ties. I have used hundreds of zip ties. And I also recommend these multi-packs of shrink wrap with the adhesive in them. And then Harbor Freight heat gun. So that's pretty much the tools that I've been using for the electrical system. I also didn't mention that there's a breaker, or this is an example breaker. Alright, I cut my wire to the length I want it so that it'll make it into my breaker box. Now if I can find my knife. I just have it. There it is.